Hello everyone, and welcome to the AI Research Roundup. I'm Alex, your host, and today is May 19th, 2025. We are looking at a research paper from Hugging Face's trending list, titled Qwen3 Technical Report, published just 5 days ago. This paper presents Qwen3, a new series of large language models. These models feature innovations like mixture of expert architectures, which use specialized internal components, or experts, for efficiency. A key idea is integrating a thinking mode for complex reasoning with a non-thinking mode for rapid responses, all managed by a thinking budget for resource control. Alright, so to give us a clearer picture of these different Qwen3 versions, the authors provide details on their architectures. Table 1 lays out the specifics for the Qwen3 dense models. These are the more traditional LLM structures. It shows model sizes from 0.6 billion parameters up to 32 billion. We can see details like the number of layers, which essentially means how deep the network is, and the context length, that is, how much text the model can consider at one time. For instance, larger dense models here support up to a 128,000 token context length. Following the architecture details, this figure then illustrates the post-training pipeline, essentially how these Qwen3 models are fine-tuned. For flagship models, there is a multi-stage process. This includes long chain of thought cold start, training for step-by-step reasoning, then reasoning reinforcement learning, where models improve reasoning by trial and error, followed by thinking mode fusion, and general reinforcement learning. Lightweight models, however, use strong to weak distillation, learning from larger models. These distinct pipelines help optimize performance for each model type. Okay, so building on those distinct training approaches, this table, Table 11, directly compares the flagship Qwen3235BA22B model in its thinking mode against other leading reasoning baselines. These are other top models used as standards for reasoning. We see it stacked up against models like Gemini 2.5 Pro. The table shows Qwen3 is a mixture of experts model with 22 billion activated parameters, meaning only a fraction of its total 235 billion parameters are active per input. Across diverse benchmarks like math and coding, Qwen3 frequently secures top scores, highlighting its competitive edge. So digging deeper into that impressive reasoning capability, these next plots explore how the flagship Qwen3235BA22B models performance scales with its thinking budget. This budget is essentially the amount of computational effort the model dedicates to reasoning on a problem. Across 4 challenging benchmarks, such as AM for math and Live Code Bench for coding, we see the solid blue line, representing thinking mode, consistently above the dashed red non-thinking mode. And, as that thinking budget increases, the model's success rate on its first attempt, or pass at 1, generally climbs in thinking mode, really highlighting its benefit. Alright, shifting focus from the flagship model to another in the series. This table, Table 22, details the Qwen332B model's performance through its key post-training stages. We see scores after Stage 2, which is reasoning reinforcement learning, then Stage 3, thinking mode fusion, where the model integrates its thinking and non-thinking operational modes. Finally, Stage 4 shows results after general reinforcement learning, a process using a multitask reward system for broad enhancement. Across diverse benchmarks, scores generally improve with each stage, particularly for Stage 4, demonstrating this pipeline's effectiveness in refining both operational modes. Okay, so building on those pipeline enhancements, this table, Table 37, really zooms in on Qwen3's multilingual performance. It presents results from the Belle benchmark, which is a comprehensive test evaluating a model's understanding across numerous languages. We can see various Qwen3 models, from the 32B down to the 1.7B, stacked against other models, across a wide range of language families, like Indo-European, Sino-Tibetan, and Austronesian. Qwen3, especially in its thinking mode, consistently achieves high scores, often the best, showcasing its impressive gains in multilingual support. So, beyond its strong multilingual capabilities, this paper on Qwen3 really underscores a significant leap for open-source LLMs. Key takeaways are the innovative integration of distinct thinking and non-thinking modes and its advanced mixture of experts, or MOE architecture. A mixture of experts model is a type of neural network with many specialized subnetworks or experts, and it learns to activate only the most relevant ones for a given task, boosting efficiency. The models were pre-trained on 36 trillion tokens, which are the basic units of text or code the model processes, leading to strong performance during inference. That is, when the model is actually generating answers or predictions. It is a versatile and high-performing family, openly available. Thanks for tuning in to AI Research Roundup.